Better even start. All right, Bismillahirrahmanirrahim. So today we are just going to be talk about the proof, and in today's class we will done by proof by exhaustion and disproof by the counter example. Okay, the proof by exhaustion in this one, what we have to do, you have to remember that in the deduction, what we are doing, we are just going to be using the algebra and the logics, and by using that one, we have to prove that the statement is true or false. In the same way, here we will not use the algebra. Here what we will do, we are going to be take all the possibilities, and taking all the possibilities, we will show that the given thing is true. So in this one, we are just doing proving by testing every possibility in a statement. In the statement, if he is going to be given the possibilities, so we have to check all that possibilities. All right. In this one, it is not, we will not do that. We have to just take some few values, and on that few values, we have to be make the make our decisions. So we in this one, we are just going to be check all the possibilities that is going to be possible. Let's try to understand it with the help of an example. For example, he says that prove that if x is an integer in the range from 0 to 5, then you have to prove that x squared plus 2x plus 1 is always a square number. So this is the statement is given, and we have to prove it by the exhaustion. In exhaustion, what we will do, we are just going to be finding all the possibilities that we can, and accordingly, we are just going to be uh, find the answers. All right. For example, let's do it. For example, if I'm just going to be the possibilities we have from 0 to 5. So I'm just going to be do it. We have to put x is equal to 0. So I'm going to be get 0 square plus 2 into 0 plus 1. It will be 1. Look at here. 1 is a square number. You have to take the second possibility. You have to put x is equal to 1. It is going to be 1 square plus 2 into 1 plus 1. That will be 4. And 4 is the square of 2. So this means that it is a square number as well. In the same way, if I'm going to take the next number, x is equal to 3, 2, so it is 2 square plus 2 into 2 plus 1. 2 square is 4, 2 times 2 is 4. 4 12 is 4, it is 8, 8 plus 1, it is 9, and 9 is the square of 3. So look at here, it look like all the values are in the square numbers. If you have stop here and says that x square plus 2x plus 1 can be are going to be a square numbers, so then it is not exhaustion. Okay, if you are doing the exhaustion, so you have to be find all till here. Obviously, you will understand that it is a square numbers. But in the exhaustion, you have to find all the possibilities. You have to check all the possibilities. You have to proving by testing every possibility in a statement. So in the statement, we have the possibility from 0 to 5. So we have to check at 0, check at 1, check at 2. We have to check at 3. So it will be 3 square plus 2 into 3 plus 1 is equal to Yes, that will be
And
9, 9 plus 6, 15, 15 plus 1. It is 16. So that will be
4 square.
4 square. In the same way, if I'm just going to be substitute x is equal to 4, so it will be 4 square plus 2 into 4 plus 1. 4 square is 16. 16 plus 8, that will be 24. 24 plus 1, it is 25. That is the square of 5. Now, substitute 5. It will be 5 square plus 2 into 5 plus 1. It will be 36. So
36.
that will be 6 square. So look at here. I have to check all the possibilities. So I can say that x square plus 2x plus 1 is always always square number in the range of 0 to 5. All right. And for example, if this is the same question, this is the same question, and I need to be do it by the deduction method. If I'm just going to be do the same question in the deduction method, what I will do in that situation by the deduction method, I'm just going to be use the algebra. We have x square plus 2x plus 1. I'm just going to be doing the completing square method. So it will be x plus 1 whole square minus 1 whole square plus 1. Yes, everyone, have you remember the completing square method?
Yes, sir. Yes, sir.
So x plus 1 whole square plus 1 and minus 1 will be cancel out. You will get x plus 1 whole square. So you clearly you can see that x plus 1 square is a square number. So always we are just going to be get a square numbers. If I'm just going to be do this question by the deduction method, I have to use the algebra. But here I'm not going to use the algebra. What I have to do, I just have to take all the possibilities at 0, at 1, at 2, at 3. But obviously, if it is infinite values, it is not possible to do it by extraction method. Yes, everyone. Any question till here?
No, sir.
No, sir.
All right. Let's do another question. For example, if he says that prove that all two digits square numbers either a multiple of 5, one more than a multiple of 5, and the C option is 1 less than a multiple of 5. So this is the statement. So look at here. What is the statement? He says that prove that all two digit square number. So two digit square numbers are between 10 and 20. 16 is a square number. The next square number is 25, 36, 49, 64, 9 squared is 81, 10 squared is 100. But 100 is 3 digits. I just need to be take the 2 digit square number. So look at here, I just going to be take all the 2 digit square numbers. Yes, everyone. Any question till here?
No, sir.
Okay, what he says that there will be either a multiple of 5. So yes, is there anyone that is a multiple of 5?
25.
Yes. So look at here, it is a multiple of 5. Okay, if it is not multiple of 5, then one more than multiple of 5. Is there
16 to
any
36.
16? Because 5 times 3 is 15. 15 plus 1, it is 16. So simply it is the B option. It is the B option as well. Yes, any other option for the B? One more than a multiple of 5? Yes, everyone. Is there any value of one more than a multiple of 5?
81.
Yes, we have the 81 because 80 is multi 8 time, I think 60. Yeah, 16 is 80 plus 1, it will be 81. All right, one less than a multiple of 5 means you have to multiply by 5 and you have to subtract 1. So that is the option. That is the C option because C times 10 is 50. 50 minus 1, it is 49. 64, you have to be 5 multiplied by 13, that is 65. 65 minus 1, that will be 64. So it will be 5 multiplied by 3, that is 15 plus 1. It is clearly 5 multiplied by 5. It is 5 times 7 is 35 plus 1. This will be 5 multiplied by 10, that is 50, minus 1. This will be 5 multiplied by 13. Yes, right, it is 13, right?
Yes.
And this one is 5 multiplied by
45. Oh
45
no.
or 16
16, 16, yes.
plus 1. So look at here, all of these values are either will be a multiple of 5 or either will be multiple of 5 plus 1 or either will be multiple of 5 minus 1. So yes, this statement is true. We have proved. Yes, everyone. Any question till here?
No, sir.
All right. Let's take another example. For example, he says that prove that 37 is a prime number. We have to show that or prove that the 37 is a prime number. So how we can prove it? So obviously we are just going to be take all the possibilities. So this means that we need to be checked till 36 number, or you have to check it on 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Obviously, 13 is itself a prime number. You don't have to be go for it. So you have to check all the numbers and you have to be literally show all the values. Okay. Until 18, after that 18, you have to be the double is 36. So you just have to skip some of the values. Let's check it. So 37 is divisible by 1. So it is 37 because you know that the prime number is a number that is divisible by 1 and itself. So it is divisible by 1. So 37 is not divisible by 2,
No.
not divisible, not divisible by 3, not divisible by 4,
4.
not divisible by 5, not divisible by 6. And till here you have to show all the values. It is not divisible by
9.
35 until go 37. And it is not divisible by 36. And it is divisible by 37. So look at here. It is divisible by only 1 and it is only divisible by itself.
37.
So 37 is divisible by 1 and itself. So 37 is a prime number. Yes, everyone. Any question till here?
No, sir.
Yes, Ishal, Jehoram, Muhammad Ikram.
No, sir.
Sir, is there no other way to solve this question besides exhaustion?
Sorry?
Is there no other way to solve this question besides exhaustion?
In the exhaustion, basically, you have to just take all the possibilities. That's it. You have to check in each and every possibility. All right, everyone. Please do this question on your notebook. Don't skip any step because it is from 1 to 4. It is exactly the same as the first question that you have done. From 1 to 4, you have to prove that this value nq plus 1 and multiple of 7 is always 1. The difference between nq plus 1 and multiple of 7 is always 1. Yes, everyone, please try it. You have 5 minutes approximately. Otherwise, I will do. Sorry, what you're doing? Yes, I want to do it faster. You have to check by this value. It will be 2 cube plus 7, 15, 15. You have to write 7 times? 5. Okay. What do you have done here?
Sir, 4 cube plus 7 is
Yes.
71, and then you multiply minus that
You
with 7
you have
by
done it
times 1.
71. So it is 7 times 10.
Yeah, 71 minus 7 times 10. I think it's a bit scribbled, that's why you can't see. But I wrote 7, 10 is the difference is 1.
All right. Therefore, the statement it is 2. Yes, any other one have done this question? Yes, everyone, I'm waiting for you. Yes, Muhammad Ikram, Ajay Khurram, Ishal, you are doing.
Yeah.
Yes, sir.
Yeah, that's correct. Yes, everyone, Ishal and Muhammad Ikram, if you are stuck, just let me know. I will do it. Or I might
I got
miss
the
it,
same
right?
answer, sir.
Can
Or
you do it? I'm like stuck halfway through.
all right, look at here. The statement he says that prove that the difference between n cube plus 1 and multiple of 7 is always 1. So between 1 and 4. So you have to substitute 1, 2, 3, 4, and 5. So till 4. So you will have substitute 4, it is 8, 2, it is 15, 3, it is 34, 4, it is 71. All right. Now we have to be checked that take the multiple at near 8, the multiple of 7 is 7 times 1 is 7. Take the difference, it is 1. 15. Near 15, the multiple of 7 is 14. So 7 times 2 is 14. So 15 minus 14, it will be 1. The multiple of 7 that is near 34, that is, yes, Ishal. The multiple that is near 34. Yes, Ishal. You have to multiply any number with 7 and you will get the number near 34. Ishal, are you here? Yes, Muhammad Ikram.
Yes, sir.
Yeah, the number that is near 34. That is multiple of 7. Yes, Muhammad Ikram, tell me the
Yeah.
number that is the multiple of 7 and it is near 34.
Uh, 5.
It is 35. Because I know that the 35 can be written as 7 times 5. So 35 minus 34, it is 1. In the same way, I substitute it is 71. So near 71, the multiple of 7 is 70 because can write it as 7 times 10. So 70 minus 71, it will be minus 1. So the difference is still 1. So in this way, you have to prove all the values till 1 to 4. So every time the difference is 1. So this proves that the difference between n cube plus 1 and a multiple of 7 is always 1. Yes, Ishal, it is clear?
Yeah.
Okay, now we have the last thing is left, and inshallah in the next class we'll do the practice session. The next thing is that is you have to do it disproof by counter example. Okay, examiner is going to give you any statement, and you just have to give one opposite example and to disprove the statement. So in this one, what we have to do, we have to give the an example. You have to give the example that is not true. For example, he says that the sum of two different prime numbers is always even. This means you have to take the difference between the two prime numbers. The sum of the two prime numbers, two different prime numbers is always even. For example, if I'm just going to be add 7 is a prime number, 11 is a prime number, you will add them, the answer is 18, and 18 is even, right? You have to take 7 plus 13, it will be 20. It is also the prime number. 3 is a prime number, 5 is a prime number, you will add them, the answer is 8. That is even, right? So in this statement, we have to give an example in which you will add the numbers, add two prime numbers, and the answer is not even. Yes, everyone. Give me the example.
1 plus 2,
What is not a prime number?
uh, 3 plus 2.
Yes. If you have to be add 2 plus 3, 2 is a prime number, 3 is a prime number, and their answer is 5. And it is, now look at here, you just have to give one example that shows that it is not the even numbers, so we can say that statement is not true or it is false. We have to prove it by just giving the example. Let's take another example. The product of two irrational number cannot be rational. But obviously you have to know that what is rational number. Rational numbers, the numbers that are divisible by uh, that are possible to write into the form of fraction, and the irrational numbers that are not possible to write into the form of fraction. For example, if you have to multiply the pi multiply by root 2, it is pi root 2. So yes, it is irrational. So means the statement is true. The root 2 times root 3, the answer is root 6. That is 2 as well, because root 3 is an irrational number. You have to take root 3 multiply by root 3. Yes, what is the answer?
3.
That is 3. So look at here, it is root 3 is an irrational number. Root 3 is an irrational number. I multiply the two irrational numbers. The answer will become rational. This means that this statement is false. So it means that the product of two rational numbers can be rational. So statement is false. In the same way, for example, he says that writing a plus b whole square is equal to a square plus b square. We know that in actual it is a square plus 2ab plus b square, right? Is always incorrect. He says that you have to show that it is always incorrect. So let's check. If you have to take 1 and 2, their square will be 3 square, it will be 9. And you have to take 1 square plus 2 square, it will be 5. Yes, it is true. They are not equal. You have to take any other example, like you have to be take 2 and 5 whole square, that is 7 square, it will be 49. You have to take 2 square plus 5 square, it will be 25. 25 plus 4, it is 29. Yes, look at here, they are not equal. So yes, is there any example in which they are equal? There is any possibility in which these things are going to be equal?
1 second.
Yes, Ishal, Wajih Karam, Mohammad Ikram. Think about the possibility in which they will be equal. Let I'm going to give you. For example, if you had to take 0 plus 1 whole square, that will be 1 square, it will be 1. And you have to take 0 square plus 1 square, that is 1. So look at here, the statement will become false because I get these two values equal. In the same way, you can take any both zeros, you can take one of the value will be 0. So this statement is always will be equal to a plus b whole square is equal to a square plus b square. Yes, everyone, it is clear how to disprove by the counterexample.